Hello, my name is Morgan Jones, and this is the final project for Honors Chemistry. I chose number 11 of the final project document that we're supposed to select. Um, and this is the tutorial video on how to complete this problem. So this is the agenda of what we need to do for this stoichiometric problem. Read at your own risk or read at your own pace. Just pause this video and look at it. Okay, so first off, we must balance this equation to move forward with this problem. So the equation given was carbon monoxide plus hydrogen gas, which produces methanol. Carbon monoxide is CO plus H2, which is carbon gas. We use 2 for the subscript for hydrogen gas because it's a diatomic, and all diatomics have a subscript of 2. That produces methanol, and methanol is CH4O. But as we can see here, this chemical equation or this synthesis reaction is not balanced. So in order to balance it, we must find a balance in these hydrogen atoms, since our carbon and oxygen on both sides are already balanced. They on both reactant and product sides, they're 1 carbon and oxygen on both sides. So the only difference between these, the reactant and the product, is the hydrogen, and in this case the reactant has only 2 hydrogen atoms, and on the product side there are only 4 hydrogen atoms. So by placing a coefficient of 2 in front of the reactant hydrogen to balance the reactant and product sides, to balance the reactant and product sides of this chemical equation. This synthesis reaction, the ratio is 1 to 1, and we have balanced this synthesis reaction of carbon monoxide reacting with hydrogen gas to produce methanol. Now it's time to convert our given units for both reactants to moles of methanol. Converting. Now we are going to convert our given reactants in whatever unit we have into moles. So for the first problem, let me read the problem first. Carbon monoxide and hydrogen gas react in a synthesis reaction to produce methanol. If 5.47 times 10 to the 25th power molecule, of carbon monoxide react with 9.0 liters of hydrogen gas at SCP, how many grams of product will be produced and how many grams of excess reactant will be left over? So starting with our first reactant with carbon monoxide, we have 5.47 times 10 to the 25th power molecules, which will be converted to the moles of carbon monoxide, 2 moles of methanol. And then the next one will be the reactant of hydrogen gas, 9.0 liters. That will be converted to hydrogen gas, the moles of hydrogen gas to the moles of methanol. And this is just the process in which the conversion happens and how it happens and how it's set up. So, and we put so how can I explain this in the most simplest way possible? When we are using molecules and we're converting them to moles or grams or a different kind of unit that isn't molecules or atoms or particles, we use 6.02 times 10 to the 23rd molecules, because for every mole there is 6.02 times 10 to the 23rd power molecules or atoms or particles in a given reaction. So, and to not have any exponents in our moles of methanol, we will put in parentheses of our molecules. We'll put 5.47 times 10 to the 25th power molecules of carbon monoxide. We'll put parentheses around that, and then parentheses around 6.02 times 10 to the 23rd power molecules of carbon monoxide, and put parentheses around that so the exponents can cancel out, and we get a number, which are moles, and we don't have exponents added to that answer or whatever. So we do these two molecules, multiply that times 1, and you will get 90.86378 moles of methanol. This is our first, I guess you can say, answer that we will definitely use later on to find the excess reactant. Okay, so now using our other reactant, hydrogen gas, we will be converting liters to moles of hydrogen gas to moles of methanol. So starting with 9.0 liters of hydrogen gas. Just like our previous problem, we use for liters 22.4 liters because for every mole there is a volume of 22.4. And this is, I believe, no, actually, if I go back, the 6.02, that is, bear with me, Avogadro's number that we use to convert atoms or particles or molecules to a different unit. Excuse me. But, I'm going everywhere. But for liters specifically, we use 22.4 liters to convert liters to moles, in this case, or grams, or a different kind of unit. So we divide 9.0 liters of hydrogen gas from 22.4 liters of hydrogen gas. Then we multiply it by 1 divided by 2 of hydrogen gas. We multiply the 1 mole of methanol divided by the, you can just use a half. I think that's just easier to think about. So you're dividing the liters, the 9.0 from the 22.4 liters, and you're multiplying by half, and then you get 0.200892857 moles of methanol. And as you can see, this answer specifically has the least amount of moles, so we'll be using this mole to convert to grams, from moles to grams for methanol. Yes, and as you can see here, our least amount of moles between both equations is the 0.200892857 mole of methanol. We will now use this given mole, to convert it to how many grams can be produced of our product methanol. So we'll be converting the moles to grams. So we'll be multiplying the least amount of moles, which was that number, times the molecular mass of methanol. So we'll add the elements. We'll add carbon plus hydrogen times 4 plus oxygen, and you can divide by 1 if you want to, but you'll just still get the same number. You'll get 6.44 grams of methanol. If you want the whole number, give me 1 second. Can't really see this because I'm doing it on my calculator at home. To multiply that times 32.05, 0.042. All right, and then you'll get 6.437008927 grams. I just converted it, so it left me some space. But yeah, so this is the amount of grams we need to produce our product methanol. Now we will be finding the excess reactant in grams, but first we must find the original amount of the reactant we are looking for to figure out whether our excess reactant is true and is less than its original value. So by converting carbon monoxide molecules to the moles of carbon monoxide to grams of carbon monoxide, because we have excess. There is more carbon monoxide than we originally need to make ethanol. So we're trying to find this excess to see how much we have left over. So by using 5.47 times 10 to the 25th power molecules of carbon monoxide again, divide that by 6.02 times 10 to the 23rd power molecules of carbon monoxide. We're going to then multiply by the molecular mass of carbon monoxide to get the original reactant value, to see if for the next problem, our excess reactant is less than this original value. So we divide by our molecules, and then multiply by the molecular mass of carbon monoxide, which is 28.01, and then you should get 2,545.094684 grams of carbon monoxide. So this is the original value, and whatever we get for our excess reactant should be less than this. Okay, so before we do anything, we have to find the difference in moles of our previous problems where we found from the reactants that we were given to convert to methanol in moles. We are going to find the difference of those moles of methanol and then use that to convert to the grams of methanol. So if you subtract, I condensed these numbers because I had to make room for these numbers, but we're going to subtract the 90.86 moles of methanol from 0.201 mole of methanol, and you should get 90.66 moles of methanol. Using this number, you will divide by the mole of methanol times the mole of carbon monoxide, divided by the mole of carbon monoxide times the molecular mass of carbon monoxide to find the excess reactant of carbon monoxide. Once you have completed this conversion, you should get 2,539.467676 grams of carbon monoxide. And as you can see, this number is indeed less than our original reactant of carbon monoxide that we tried to solve to see if it was actually less or greater. Because if it was greater, we did something completely wrong. But now that it's less, we know that we did something right, and we can move forward. And if you need extra help, you could have used the stoichiometry island diagram that shows you what you're converting and how you're getting there. So for our first reactant, we went from particles, I believe, but that could be, molecules or atoms. So you're going from particles to moles to mole. That's like 2 steps right there. 2 steps in which we did. And then the second conversion was from the volume to moles. And then from that mole, we went to the mass, find the mass of methanol. Then that was how much product we can produce. And then once we did that, we subtracted the moles from each other, and then we found the grams of the excess. So our concluded answers: the product produced is 6.44 grams of methanol, and our excess reactant is indeed carbon monoxide, which is 2,539 grams. But our limited reactant is indeed hydrogen gas, because we used it all. We used all of it, and there's no excess, but there is excess of the carbon monoxide. And that is it on how to solve the stoichiometry stoichiometric problem, number 11 of the final project. Thank you and have a great day.